All right, good morning. Happy Thursday. All right, so we have quite a few absences and I'm not sure why. I only noticed one person that's doing AP testing. And so just a reminder to don't mess up your grade here at the end. Class isn't over, school isn't over. So make sure that you finish what you start and be careful. I have seen students that have like a solid B or C plummet at this point because they just stopped doing work. I'm not sure why, but don't do that. Make sure you're working till the end, trying to pass the class. So yesterday, what we did is I took some questions, or we looked at some questions on lesson 10.2. And so I'll take any questions you have on that. Last night, we turned in lesson 10.1. And so any questions about 10.2? And then I'm planning on teaching a new lesson today on 10.3. As far as books go for seniors, you're not turning in your books. So you can't turn in your books till we're done. So don't plan on turning in your pre-calculus book until probably after you take the final. That would be a good time to turn it in. Otherwise, we're using the book in this class. I don't know about other classes, but we're using the book in this class. So that'd be foolish to turn in your book. All right, especially before the final, because you're gonna need your book in order to study for the final. All right, talking about the final. The final will be given during class. Your final is on Thursday, May 20th. So Thursday, May 20th during class, you'll have 80 minutes to take the final. And basically what we've done this semester is we've looked at 19 sections. So you can expect to be tested from those 19 sections. I will tell you what the sections are. And then you can expect problems from each of those sections. So. All right, any questions about the final right now for seniors? Okay. Any questions you want to ask me from lesson 10.2? So that was the problems we were doing yesterday in class. Lesson 10.2, any questions? That was the arithmetic sequence and series, which is the sum.
Wait, so Miss Bridge, about the final, so it's just gonna be based off of like the 7.1 through 10 point, I don't know how far we're gonna go, but it's gonna be based on those, right? That we did this semester?
Oh, we did more than 7.1.
No, I know.
We did
Yeah.
2.1 to 2.6. I'm sorry. 2.1 to 2.8, 3.1 to 3.4, 7.1, 7.2, 7.4, 7.5. And now we're doing 10.1, 10.2, 10.3. So all of that will be on the final.
Okay.
Just to let you know, if you're curious, the next exam is going to be on 10.1, 10.2, 10.3, and that's going to be on May 17th. So May 17th, that's a Monday, and you're going to be taking the exam during class. So this is the first exam that will not be on a Tuesday. So if you want to mark your calendars, the exam 10.1 to 10.3 is on May 17th during class. All right, last call, anybody want to ask me about lesson 10.2? All right, lesson 10.3 is similar because it has to do with geometric sequence and series. So in 10.1, we just talked about regular sequence and summation notation. In 10.2, we talked about arithmetic sequence and series. So that's when you have a common difference. And today we're going to talk about geometric sequence and series. So in this case, you have to have a common ratio. So let's take a look at it, lesson 10.3. Do you guys want to ask me anything else before we get started? So like I said before, sequence are terms separated by commas. Series is a sum where the terms are separated by plus signs. So in 10.2, we looked at arithmetic sequence and series. Now we're looking at geometric sequence and series. So what is the geometric sequence? It's a sequence in which the ratio, now ratio means fraction. So it's where the ratio of successive terms, one right after another, is a constant. And this constant is called R, and that is called the common ratio. And common meaning the same. So this lesson is going to seem like we already did it, and we haven't already done it, but it's going to seem similar to the arithmetic sequence and series. So the first thing they're going to ask is the series geometric? Is the sequence geometric? And so you have 8, 12, 18, 27. So that's an infinite sequence. We want to know, is it geometric? So now instead of subtracting, what we're going to do is we're going to take 12 divided by 8. So we're still going backwards. 18 divided by 12, 27 divided by 18. And we want to know, are those the same? Well, if you divide the top and the bottom by 4, 4 times what is 12? 3. 4 times what is 8? 2. So we're simplifying. What goes into both of these? 6. So 6 times what is 18? 3. 6 times what is 12? 2. On the next one, these are both divisible by 9. 9 times what is 27? 9 times what is 18? So there is a common ratio, and that means that this is geometric. So yes, it is. And if somebody asks you why, it's geometric because it has a common ratio. So that's the justification. So basically, to find the common ratio, you're going to divide the previous terms by the successor. So arithmetic, we subtract. Geometric, we divide. So on the exam or on the final, make sure you read the problem. Are they telling you it's an arithmetic sequence, or are they telling you it's a geometric sequence? Because that tips you off with if you have a common difference or a common ratio. Let's do another one. All right. So is this geometric? You would take 10 divided by 6, 15 divided by 10, 21 divided by 15. So if you divide the top and the bottom by 2, 2 times what is 10? 5. 2 times what is 6? Divide the top and bottom by 5. 5 times what is 15? 5 times what is 10? And just to make sure I didn't make a mistake, let's look at this one. Divide top and bottom by 3. 3 times what is 27? 3 times what? No, this is not geometric. And the reason why is there's no common ratio. So hopefully this is pretty simple. All you have to do is you have to work with fractions. You have to know how to simplify fractions. That's it. Okay, is anybody confused about this, or anybody need me to show you more details about this? So I didn't really show the work. If you wanted to show the work, you could divide the top and the bottom by 2, divide the top and the bottom by 5, divide the top and the bottom by 3. So if that helps you to show the work, then do that. Divide the top and the bottom by 4, divide the top and the bottom by 6, divide the top and the bottom by 9. Can you guys unmute yourself and let me know, are you guys okay or no?
Yeah, I'm okay.
Anybody else? Areli, Destiny, Edwin, Marcos?
I'm okay.
Yeah, that's fine.
All right, so the next objective is writing the terms of a geometric sequence. Notice it says geometric. And so this example, like the other lesson, will say write the first 5 terms. Of the geometric sequence. So that tips us off. So this tips us off that this does have a common ratio. If it did not say this, we can't do the problem. So this tells us this is geometric, and they're saying that a sub 1, so the first term is 6, and they're telling us that the common ratio is 1/3. Now, before we just guessed, and remember we said guess and check, and that guess and check it's a good method if we're doing a problem where we can guess and check. We don't want to use guess and check if it's a problem that's going to take up 3 hours of our life. So that's the thing. Guess and check is a good method. There's nothing wrong with it. All right, here we go. So the first term is 6. So how would you get the second term? If the common ratio is 1/3, what would the second term be? Now think about this. To get the common ratio, we divide. So wouldn't you think we do the opposite? So to me, wouldn't you think we would multiply 1/3 by 1/3? So we would say that 6/3 is 2. I don't know, let's see. If our first term is 6 and our second term is 2, is 2/6 1/3? Yes or no?
Yes.
So
Yeah.
with the third term, if we took 2 and multiplied by 1/3, that would be 2/3. So let's see if that works. Is 2/3 divided by 2. Now notice I didn't write a complex fraction. I didn't write it as 2/6. I wrote 2/3 and I wrote it out like that because it's confusing if I create a complex fraction. So doesn't this mean 2/3 times the reciprocal? So don't we get 1/3? Yes? So aren't we starting to think that if I want to find the first 5 terms, I just take the term times the common ratio?
Ms. Birch, how do you find the reciprocal again?
You change it to multiply and just flip it. So that's 2/1. So the reciprocal is 1/2.
Oh, okay.
Okay. Okay, so now we're going on, I'm going to write over here, a sub 4, we're going to take 2/3 and we're going to divide by 1/3. So that would be, not divide, I'm sorry, multiply. We're going to multiply by 1/3, so that would be 2/9. So let's see if that works. If we take 2/9 divided by 2/3, wouldn't that be 2/9 times the reciprocal? And wouldn't that be cancel the 2's, cancel with that, and you get a 1/3? So there's 2 things going on here. We're trying to write a sequence with a common ratio, but over here, we're checking to see if it works. So one more. So we're taking 2/9 and we're going to multiply times 1/3, which is going to be 2/27. So let's take 2/27. So 2/27 divided by 2/9, do we get 1/3? So this would be 2/27 times the reciprocal. So once again, the 2's cancel and we get 1/3. So that is our geometric sequence. But the point is, do you see how we got it? Did you guys get this over here? So we multiplied each term by 1/3. So that when we write the sequence, when we divide 2 divided by 6, 2/3 divided by 2, 2/9 divided, that we get a common ratio of 1/3. So do you remember with the arithmetic sequence, remember we took the term and added the common difference? Remember? We added the common difference, added the common difference, added the common difference, so that when we checked it, we could subtract and get the common difference. Remember? So now with a common ratio, we're multiplying by it so that when we divide, we get the common ratio of 1/3. So it kind of works its way out that we're multiplying to get the sequence, so that we're multiplying by the common ratio to get the sequence, and we're dividing to get the common ratio back. If you guys have any questions, I'm not working another problem like this. So if you have any questions, ask me. Last call. Questions? Questions about the actual math that I'm doing? Do you see I'm cross canceling? Okay, you do realize you cannot cancel with division. So you cannot cross cancel with adding, subtract, or divide. The only time you can cross cancel is with multiplication. Therefore, with division, we change it to multiply and take the reciprocal, and then you can cross cancel. Okay, last call. Are there any questions? I'm going to erase it. All of this work over here that I just erased, it's just me checking myself. You actually don't have to do that, but I put it in your notes just so you could see how I'm checking to make sure I'm doing the problem correctly. All right, the third objective is using a formula for the general term. Of a geometric sequence. And once again, you need this sheet, and it's right down here. This is the rule for a geometric sequence where my finger is. So it's on this sheet. A little more complicated. So once again, this represents the nth term. And what I mean by that is it the 16th term, the 100th term, the 70th term? This represents the first term. R is the common ratio. And you see that N right there? That's the subscript. So in other words, if you're finding a sub 20, that N's going to be a 20, and that's a power, by the way. If this is a sub 99, that N would be 99. So this is your formula for the general term. This is your rule. Okay, so look what they're going to do. They're going to say, find the 8th term of the geometric sequence. Now, this is where it could be confusing on the final. You have to read this because there's going to be a problem that looks similar that's going to say, find the 8th term of the arithmetic sequence. So you don't want to get the rules mixed up. So if it says geometric sequence, you're going to use the geometric formula. If it says arithmetic, make sure you use the other one. All right, so this says, find the 8th term of the geometric sequence where a sub 1 is -4 and the common ratio is -2. So we're going to write down our rule or our formula. A sub n is equal to a sub 1 times r to the n minus 1. Now you guys realize that means times, right? So that's saying the first term times the common ratio. So here we go. So we're going to find the 8th term. And the first term is -4. And you want to make sure you put that r in parentheses because being multiplied. So the r is -2. And that would be 8 minus 1. So that's it. That's it. And we've done a lot of basic math to do this correctly. So here we go. Do not multiply before you evaluate a power. Remember, please excuse my dear Aunt Sally. So we have to evaluate the power first, which is 7. We have to evaluate the power. What's a negative raised to an odd power? Come on, guys. What's a negative raised to an odd power?
Negative.
What's a negative raised to an even power?
Positive.
Right. All right. So now in your calculator, we're not going to put negative in the calculator. We already know it's negative. What's 2 to the 7? So what's 2 caret 7?
128.
All right, so here we go. What's a negative times a negative? A positive. So what's 128 times 4?
512.
512 is the 8th term. So this is not a sum. We are not adding. They are saying that with the sequence starting with -4 with a common ratio of -2, the 8th term is 512. All right, do you guys have any questions? All right, do you guys understand exactly what I did here? You cannot say -4 times, you would violate the order of operations, you would get the wrong answer. So you have to do exponents first. So this would be -2 quantity to the 7th. Remember that a negative to an odd power is negative, a negative to an even power is positive, and now a negative times a negative is a positive. Do not mess up on the negatives. Okay, any questions about, you guys want to do another one of those? Or are you guys okay?
I'm fine.
Yeah, same.
Okay, anybody want to do another one?
I'm fine.
Okay. So on this one, the 4th objective, we're going to use the formula for the sum. And remember what I said sum means. That means series. So for the sum of the first n terms, and look what they're saying, of a geometric series. Well, they're saying the sum of a geometric sequence, but they mean series. Sum means series. I don't know why they write it like this in this book. Anyhow, so on the final, you want to make sure that you notice geometric, so you don't use the arithmetic one. You want to use this one, the sum of a finite geometric series. All right, so let's look at it. S means sum, add. This is equal to a sub 1, and then you have 1 minus r to the n divided by 1 minus r. All right, so this S is the sum or add, the sum of the first n terms. And so if this was S sub 10, it means you're adding the first 10 terms. If this was S sub 100, you would be adding the first 100 terms. S sub 14, you're adding the sum of the first 14 terms. Now notice that that n and that n are the same. And so if that's 14, you're going to put a 14 there. So this does correspond to the subscript. R, of course, is the common ratio. And you know what A sub 1 is. That's the first term. All right. And I should say
Ms. Birch, what do
something
the
here
R's
too.
mean again? What does that say? Common ratio?
The common ratio,
Okay.
R cannot be 0 because you can, I'm sorry, R cannot be 1 because you can't have a 1 in the denominator. So you had a 1 in the denominator, you have a 0. So R cannot be 1. All right, so we're going to find the series, also known as the sum of the first 8 terms. Of the geometric sequence. And let me warn you about something. On the test, you want to make sure you use the formula, because I realize this is an easy problem, but if I make that 54 terms, you're going to be forced to use the formula. So just know that I'm giving you an easy problem to use the formula. You're not counting these out. You're not adding it, the first 8 terms by hand. We're not doing that. I want to know that you can use the formula in case I put a big number there, that you actually know how to use the formula. All right, so S sub n is equal to A sub 1 times 1 minus R to the n over 1 minus R. Okay, I would pay close attention right now because this is tricky. First of all, we want to find the common ratio. All right, and I didn't write down the sequence, so I got to write that down. Okay, so the sequence is 2, 2, -8, 32, -128, ... So to find the common ratio, we're going to take -8 divided by 2, 32 divided by -8, and -128 divided by 32. So just like the common difference, we're taking that one, divide by 2, that one, divide by -8, that one, divide by 32. So this turns out to be -4, -4, -4. So our common ratio is -4. So we have S sub, we're finding the sum of the first 8 terms, S sub 8 is equal to the first term times 1 minus a -4 in parentheses raised to the 8th power divided by 1 minus a -4. So there's a minus in the rule, and our common ratio is negative, so there's two negatives. Do not write 1 plus 4 because you just violated the order of operations. So this is not 1 plus 4 because you have to do a negative to the 8th power first. So what you have here is you have, let me use brackets again. You have 1 minus a negative to an even power is positive. So that'd be 1 minus what? A negative raised to an even power is positive, but this negative is still there. What's 4 to the 8th?
Four to the eighth.
Yep.
65,536.
And on the bottom would just be 1 plus 4 or 5. So the bottom, you can say 1 plus 4, but on the top, you cannot. All right, so this turns out to be, you can cancel those if you could, but you can't. So this would be a negative 6, 5, 5, 3, 5, because a negative and a positive depends on opposites subtract, over 5. So it's going to be a negative, and you can use a calculator for this. What's 65,535 divided by 5?
$13,107.
13,107?
Yeah.
And that would be divided by 5? Or no, that's divided by 5 already, right? Okay, so what's 13,107 times 2?
Uh, 26,214.
26,214?
Yeah.
All right, now I actually did an easier problem than in my notes. So can you guys, are these numbers right? Is 65,535 divided by 5, 13,107?
Yeah.
Okay, because the problem in my notes is harder than this. So I did an easier problem. Last problem. They want us to find the sum of 1 to 10 of this rule. We're not going to do this by hand and put in a 1, put in a 2. We're going to use the sum formula because they do say that it's geometric. So the sum formula is a sub 1 times 1 minus r to the n over 1 minus r So we're finding the sum of the first 10 terms, right? 1 to 10. The first term we can find by putting in a 1. So a sub 1 would be 6 times 2 to the 1, which would be 6 times 2, which is 12. And now we need the common ratio. Well, how do we find the common ratio? We could find a sub 2, which would be 6 times 2 to the 2, which would be 6 times 4, which is 24. And we can just say 24 divided by 12 is 2. Did you guys see how I found it? A sub 1 is 12. If I find a sub 2 by putting in a 2, 24 divided by 2 is 2. So the common ratio is 2. So this would be 1 minus 2 to the 10th divided by 1 minus 2. So here we go. That negative is not part of the power. What's 2 to the 10th?
$1,024.
So check this out. Watch how careful I'm going to be. A negative and a positive depends on the bigger number. This becomes 1023 over a negative 1, and a negative divided by a negative is a positive. So what's 12 times 1023?
From 12,276.
Yeah, that's correct. That's correct. Good job. Okay, now that's the lesson. And if you're going to get confused on anything, it's just going to be this basic math stuff. So please ask me if you're wondering, where do the negatives go? What's going on? Because if you mess up, it's going to be on a negative. So remember that this is not a part of the power. So this is a minus, it's only 2 to the 10th. So that minus is still there. It's not part of the power. This minus is part of the power because r was -4 and it's r to the 8th. So that would be the quantity of -4 to the 8th power. This is 2 to the 10th. So that negative does not go away. That negative right there does go away. Remember, a negative and a positive depends on the sign of the bigger number, and a negative divided by a negative is a positive. Over here, a negative divided by a positive is a negative times a positive would be negative. All right, that is the lesson. Do you guys want to ask me any questions? Okay, here's what I want you to do then. For the rest of the period until 10:45, you're going to go into your Math Wizard teams and I want you to work the problems in this lesson. So what I would do is I would do problem number 1, and then I would try problem number 9. I would try to do a problem in each section with your team to see if you can do it. Okay, now I'm on page 1073. Once again, this is lesson 10.3 on geometric sequence and series, and that's what I would do. In the meantime, I'll post the lesson. now that I finished teaching it, I know what I can make the due date. And so I'll just make sure that I posted it if I haven't already, but you don't need me to post it. 1073, we're doing the odds. But I will post it in the next 5 minutes. Okay, any questions about what you're doing? Lesson 10.3, you're doing a problem in each section with your team to make sure you understand what's going on. All right, I'll see you and take attendance in the Math Wizard teams. All right. We're not reporting, actually, should we report back? Okay, we won't report back today. So class is over at 10:45. We will not be reporting back. All right, I'll see you in your Math Wizard team.